Hello everyone, welcome to Irfan CFPS YouTube channel. In today's session, we will explore how to select and place fire alarm horns according to NFPA 72 requirements. Watch the video till the end, and if you find it helpful, don't forget to like, share and subscribe to my channel. To better understand the purpose of notification devices like horns, strobes, be sure to check out my NFPA 72 training module class 1. We shall start with the key points that has to be remembered before we select and place the horns at appropriate locations in line with NFPA 72 standard. So let's break down some key points about notification system. So audible notification. Audible notifications can either be just tones or a mix of tones and a voice message, depending on what's needed to alert people effectively. Speakers. Speakers are great because they produce both tones and voice messages, which is helpful for more detailed announcements. Horns. Horns, on the other hand, only produce tones, no voice messages. So combining horns speaker with visuals. So horns and speakers can be combined with visual notification devices like strobes for added clarity, especially in areas where people might have hearing impairments or in noisy environments. We can go ahead with horn with strobe or speaker with strobe. Mounting height. Mounting height of the horns or speakers. So mounting height shall be 90 inches for the horn or speaker above floor and at least 6 inches below the ceiling. So I will just try to draw here the mounting height for the horn. For example, consider this as a finished floor level, and we need to place the horn or speaker audible device. So this distance shall be minimum 90 inches above floor, but from the ceiling, assume this is a false ceiling or slab. From the ceiling, this distance shall be maintained minimum 6 inch, as you can see on your screen. So this is the most important part of installation requirement. So high ambient sound. It means if the background noise level in an area is over 105 dBA, then visual notification is mandatory to ensure the alert is noticed. So if ambient sound is greater than 105 dBA, visual notification is required. What would be the maximum sound level? So the maximum sound level shall not exceed 110 dBA for horn or speakers. So we need to be mindful that the sound should not exceed 110 dBA as it can be harmful to hearing. So as per NFPA 72, this is the requirement. However, I want from you whether NFPA specify a minimum required sound level for notification appliances like horns or speakers in buildings. If so, what is the minimum dBA for general areas and sleeping areas? Mention your thoughts in the comment section below. Now let us talk about different modes like public mode and private modes. Public modes, this is when the alarm is intended to alert the occupants or everyone in the building about an emergency situation. In private mode, it targets only those specific individuals responsible for managing the emergency, like security or maintenance teams. In short, if you want to alert the occupants in the entire building, we need to consider public mode. And if you want to notify only specific people responsible for handling the emergency, we need to use private mode method. What exactly the difference and how the DBA rating will be impacted, we will go or we will understand in the next slide. For evacuations or relocation, if people needed to evacuate or relocate, the fire alarm or the horns or audible device must use the temporal 3 pattern. If there is a carbon monoxide detection in that particular area, such as in plants, the fire alarm or the horn shall use temporal 4 pattern. So basically temporal 3 pattern and temporal 4 pattern tone is slightly different. You can just check on Google temporal 3 and temporal 4 pattern difference. NFPA 72 provides a table showing the average ambient sound levels based on the location, which helps in selecting the appropriate horn dBA. For example, the average ambient sound level for business occupancy is 54 dBA as per NFPA 72, while for educational occupancy it is 45 dBA. We can see similar values for other locations in this table on your screen. Coming back to our main topic, selection of fire alarm horns. This is the table A18.4.4, which states average ambient sound level according to the location. This has been taken from NFPA 72. So here we are considering an educational occupancy, and for this educational occupancy we need to select the horn. It means we need to select the dBA rating for the horn. So in public mode, signaling must have a sound level at least 15 dB above the average ambient sound level. So this is the catch point here. What about in private mode? In private mode, it should be at least 10 dB above the ambient average sound level. Since educational occupancies, business occupancies, all these occupancies will be considered as in public mode, because we need to notify all the occupants in this particular area. Hence we consider public mode for this and decide the dBA rating, adding 15 dB to this average ambient sound level. Don't get confused, I will explain smoothly in this particular slide. So let's take an example using an educational occupancy for this particular room. First we will check this table for the average ambient sound level for an educational space, which is 45 dBA. Since we are considering public mode for this occupancy, where we need to notify all the occupants in the room or in building, we will add 15 dBA to 45. So it will come around 60 dBA. So this should be maintained in the protected occupancy. Based on this requirement, we need to select the horn. For example, if I select 60 dB horn, because the horns are, or the sound level for the horns are provided by the manufacturer at 10 feet only. So if you look at the manufacturer data sheet, the manufacturer data sheet will show the horn rating at 10 feet only. So now if I consider, for example, 60 dBA horn, it means it can reach, or the sound level will be 60 dBA up to 10 feet only. So what about this particular area? This area also has to get 60 dBA, because as long as the distance increases from this particular source, the dBA rating will be reduced. So this is based on inverse square law formula. We will discuss about that in next slide. But coming back to this particular example, so we need to select the horn rating more than 60 dBA, because we need to maintain 60 dBA in the entire room. So now if I select 75 dBA rating throughout the protected space, then in next slide we will try to look whether this is acceptable or not. So one more most important point, in areas where people may be sleeping, not educational occupancy, in sleeping areas, the sound should be at a low frequency of 520 Hz. This is an interview question as well. 520 Hz. So in sleeping areas, basically we will provide smoke detectors in each sleeping room. So these smoke detectors shall be provided with a sounder base which has low frequency of 520 Hz. From the earlier slide, we still did not select the rating for the horn. We understood that 60 dBA is the requirement for this particular occupancy. So this will be the minimum requirement, and we assumed, or we are going to select 75 dBA horn and check whether this will satisfy the 60 dBA minimum requirement for the entire room. So before we discuss about this, we need to understand the inverse square law formula. This is the formula you can see on right hand side of the screen. According to this formula, or according to inverse square law, sound pressure level decreases as the distance from the source increases. I will explain you about that as well. Currently try to understand about this particular formula. So here SPL1 represents sound level, means dBA, at reference distance D1. Please remember, the reference distance will be 10 feet always, because the manufacturer has provided the dBA rating at 10 feet. So D1 we will be able to identify. So 10 feet. SPL1 will be, since we selected 75 dBA, it will be 75, and D2 will be varies. D2 is nothing but the new distance from the source. Please make a note of it. So many students confused with this particular concept. So D2 will be from the source. So this will be D2. I'm just writing on left hand side of your screen. So D1 is the reference distance provided by the manufacturer. D2 will be the new distance. D2 will vary always whenever we try to calculate the dBA rating as the distance from the source increases. And 20 log 10 accounts for free field sound loss. No need to remember that. However, if we know SPL1, D2 and D1, we can calculate the sound level at this particular point or at D2. Now, let us try to calculate by considering SPL1 as 75 dBA and D1 as 10 feet, and D2 shall be basically, it should be double than this D1. So D2 will be 20 feet as you can see on your screen. So D1 will be 10 feet. D2 will be from the source. It should be double. So 10 into 2, it will be 20 feet. So D2 will be 20 feet. In next slide, I am going to find out what exactly the requirement or what exactly we are going to get if the distance increases from 10 feet to 20 feet. Now we already considered 75 dBA rating for this particular horn, and now our job is to check or is to calculate how the sound level decreases as the distance increases. Based on this, we will be able to find out how many number of horns to be considered in this particular area or building or a particular room. So to do this, we need to use this particular formula, which is inverse square law, and we need to enter all the details such as SPL1, D1 and D2. D1 will be, we already know it will be 10 feet. However, the D2 will be calculated from the source, and this D2 will be double the D1. So it means here it is shown 10 feet on your left hand side. So 10 feet, we need to add more 10 feet, then it will become 20 feet. So D2 will become 20 feet. So 10 plus 10 will be 20. So 20 feet. Okay. So now we are just going to place all the values in this particular formula. So we are going to get the value of SPL 2. So here D1 will be 10, D2 will be 20. This one needs to be entered here. So we are going to get about 69 dBA at this particular point, or at 20 feet we are going to get 69 dBA. Again, if we increase the distance, now for example we consider or we will add more 20 feet distance for this already existed 20 feet. So D1 will be same 10 feet because this is the reference distance. SPL1 will be 75. Now the D2 will be the new distance. So new distance, I'll just try to take some other color. For example, new distance from the source will be 20 plus 20. Since we are doubling the distance, so this will be 40. So when we enter this 40 here in D2, 40 by 10, here 75, then we are going to get some value about 63 dBA, which is satisfying our requirement since the room requires 60 dBA minimum requirement. And for example, from here again, if the room is bigger than this one, Now we are going to check, and the requirement is 60 dBA. Now again we need to use the same formula, but in this case D2 will be 80 feet because we already got 40 feet. D1 will be 10 feet, SPL1 will be 75 feet, but D2 will be 40 plus again 40. So 80 divided by 10. We are going to get about 57 decibels. Okay, in this way we need to calculate the sound levels at any distance by using inverse square law formula. Let's say we have a large room. Now how we can place the other horn? So we already know the inverse square law formula, and we know how to calculate D2 and D1, and we already selected, for example, 75 dBA horn at 10 feet. So here it will be 75, and here we got in our previous example 69 dBA, and here we got about 63 dBA. Now if the room is large, I'm sorry, just a moment, I'm not able to draw this room properly. Okay, anyhow, please try to understand the concept. If the room area is large, then I will place one more horn at this location, and I will select, for example, 75 dBA rating, and then this will cover till 10 feet. So here it will be 75 dB. Then we need to double this 10 feet, so it will be 20 feet. But here we mentioned 10 feet because we are calculating the distance from the source. The doubling distance shall be from the source. So this will be 20 feet, and from here again we need to double this one. So for 20 from the source it should be 40. So from the source means from the horn, this distance will be doubled, so it will be 40. Now we need to check whether this particular room can be sufficed with two horns. So in this way we need to calculate the number of horns, and we need to place the horns. If you have any doubts, make sure to put your comments so that I can look into that and I can get back to you. I hope you have gained some useful design knowledge from this video. If you did, don't forget to like, share and subscribe to my channel Irfan CFPS, and click the notification icon as well to get updates whenever I post any particular video related to firefighting and fire alarm systems.